Hello serverless people, Enrico here. In this video I want to explain you a feature offered by different AWS services in order to create more durable and resilient application. The feature is called Dead Letter Queue or DLQ. Now in most cases service architecture are event-based architecture, meaning that the services are triggered by an event from another service. Let's take a quick example. You have a Lambda function which has as a trigger an SQS queue. Every time a message is pushed into the queue, the Lambda function will be triggered. But now what happens if there is an error while pushing the message or an error while getting the message from the queue? And more precisely, when the error can be thrown throughout the whole architecture. Lastly, when and how the DLQ comes into play in our architecture. First of all, it's good to remember that DLQs are powered by AWS SQS queues. They are available for different services such as SNS, SQS and Lambda, and now we're gonna break into each of them to see different features. The delivery of a message fails when it's not possible for Amazon SNS to access the subscribed endpoint. There are two reasons why this might happen: client errors and server errors. Client errors happens when SNS has a stale subscription metadata. One common cause can be when you delete the endpoint. For example, you might delete the SQS queue subscribed to the SNS topic, like in this case, we have an SNS topic with an SQS queue subscribed to the topic, without also deleting the SNS subscription. So this arrow here, what is going to happen is that SNS can't deliver the message to the stale subscription. Another common cause can be when you change the resource policy attached to the endpoint in a way that SNS is not able of delivering the message to that endpoint. Let's say you change the policy and the permission. These errors are considered client errors because the client has attempted delivery of a message to a destination that is not longer accessible. We need to remember that SNS does not retry the delivery of messages that failed as the result of client errors. Server errors, on the other hand, happen when the system that powers the subscribed endpoint is unavailable, meaning that, for example, for this case, Lambda is unavailable, or when it returns an exception while processing the message from the SNS topic. When there is a server errors, SNS retries with an algorithm called backoff function, which I explained also in a previous video. Having said that, let's see how we can use DLQs for these specific services. We're going to explain in order SNS, SQS and Lambda. So as we said, SNS may receive a client error or continue to receive server errors for a message beyond the number of retries defined by the policy. In that event, what's going to happen is that SNS will discard the message. Setting up a DLQ to your SNS subscription, so if we follow this example, is this arrow here, the subscription to the AWS Lambda will keep the message regardless of the type of error. So both for client or server errors. DLQ basically give you more control over messages that cannot be delivered in the case of SNS. In the SQS use case, DLQ store the messages that fail to be processed by your consumer application. This failure mode can happen when producers and consumers fail to interpret aspects of the protocol that they use to communicate. This is not very likely when you use AWS services like a Lambda function as the consumer of the SQS queue, but maybe when you use a third-party server as the consumer, it can happen more frequently. So in that case, the consumer receives the message from the queue but fails to process it, as the message doesn't have the structure of content that the consumer expects. In this case, the consumer can't delete the message either. After exhausting the receive count in the redrive policy, SQS can basically redrive the message to the DLQ. So when should you use a dead letter queue with the SQS service? Do you use a dead letter queue with standard queues? You can always take advantage of the DLQs when your application doesn't depend on ordering. DLQs can help you troubleshooting red messages operations. Do you use dead letter queue also to decrease the number of messages and to reduce the possibility of exposing your system to poison pill messages, which basically are messages that can be received but can't be processed by your consumer? Don't use a dead letter queue with standard queues when you want to keep trying the transmission of the message. For example, don't use a DLQ if your program must wait for a dependent process to become active or available. Lastly, don't use a DLQ with a FIFO queue if you don't want to break the exact order of messages or operation. Let's say you have a process which is very dependent on the ordering messages. If you use a DLQ, this can break the messaging order and your application logic. Lastly, when to use DLQs with Lambda. So DLQs store the messages that resulted in a failed asynchronous execution of your Lambda function. This failure can happen for several reasons. Your code may raise an exception, timeout, it finished the memory, or you can even hit a concurrency limit and be throttled. So regardless of the error type, when the error occurs, your Lambda function is going to retry by default twice. You can actually configure this retry policy on your Lambda function. After exhausting the retries, Lambda can redrive the message to the configured DLQ, as you can see here again, the red arrow, and you're going to have your message in the DLQ for a later processing. And this is how the DLQ can help with your Lambda function. Alright, I hope this video on DLQs was useful. Thanks again for watching and see you on the next video.